Linear equations. Here we have 4 examples of linear equations. When we're looking at linear equations, the highest exponent on any of your variables is 1. In other words, the only exponent that can be on your variables is 1. And typically, if you have an exponent of 1, nothing is written there. Your variables can only be multiplied or divided by numbers. You also have no variables in the denominator. When you graph a linear function, you end up getting a line. Linear functions can always be written in the form of y equals mx plus b, or if you're choosing to use function notation, you can go f of x equals mx plus b. F of x and y are representing the same thing, just your output. So here, we want to know, are these linear functions? Well, your first one here is not a linear function. Why is it not a linear function? Well, you have an exponent other than 1 on your variable. Over here, is this one here a linear function? And in this case, the answer is yes. You have exponents of only 1 in your variables. You have your variables multiplied and divided only by numbers, and you have no variables in the denominator. Same idea down here for this one. This one is also a function because it satisfies all those parts of the definition of linear equations or linear functions. This one over here is not a linear function. The reason for this one is because we have a variable in the denominator. So now we need to go ahead and get these in standard form. To be in standard form, it needs to be written like this right here. Well, in this case, for standard form, A, B, and C need to be integers, meaning no fractions. Also, A, the number in front of your x here, has to be greater than or equal to 0. So in other words, the x and the y need to be on the same side. The x term has to be first. You cannot have fractions. And your a has to be positive. Well, to get these in that form, looking at this one here, you need to get the x and the y on the same side. So let's go ahead and subtract our 3x from both sides to get x and y on the same side. Well, we don't have any fractions. We have x and y on the same side, but we don't have the number in front of x to be positive. So we need to divide everything by -1 or multiply everything by -1. When we do that, it switches all of our signs. A, according to what we have up here, is what's in front of x. B is what's in front of y, and C is the number on the other side all by itself. So for this one, A is your 3. B is a -1 because it's really a -1 in front of your y, and C is your 9. Well, we want to do the same thing for the next one to try to get it in standard form. So we need to get x and y on the same side. So I'm going to go ahead and bring my 2y over by subtracting 2y from both sides. So we get a -2/3 x minus the 2y equaling our -1. Well, we need to eliminate the fraction here. We're dividing by 3. So to get rid of dividing by 3, we're going to multiply both sides by 3. So we got to also multiply this by 3. And we'll multiply this by 3, so it's a -3 over here. And just a second here. So we now have our x and y on the same side. We have no fractions, and the number in front of your x is positive. So the number in front of x is a, number in front of y is b, the number all by itself is c. We also want to do that for our last one. We need to get x and y on the same side. Well, you'll notice x and y are on the same side, but it also has a 9 hanging out there that has no variables. So we'll take that to the other side by subtracting. Now, your x needs to be the first one. Remember, when you subtract, it's really like adding a negative. And when you're adding, you can change the order, and you can add in any order you want. So I'm going to put the x's first. You then need to go ahead and get rid of the negative by dividing by a negative. So then A is your 8, B is your negative 2, and C is the number on the other side all by itself. Here we want to go ahead and graph our linear function. We want to do that by going ahead and finding our x-intercept and our y-intercept. Your x-intercept is what you get when your y value is 0, because you're wondering at where you're crossing your x-axis, and on your x-axis you're not up and down at all, so that means your y is 0. So in other words, you're taking 0, plugging it in right here for your y value. So you're going to have a negative 2x plus a 0 minus a 4 equals 0. Now all you have to do is solve it for x. So we're going to add 4 to both sides, get rid of the negative 2 by dividing by negative 2. So you now know where you're going to cross the x-axis, and that's at negative 2. Then you want to go ahead and find your y-intercept. Your y-intercept is your y-axis, where you're crossing your y-axis. And on your y-axis, you're not left and right at all, so that's why your x value is 0. So in other words, you're going to go up here, replace your x value with 0, and solve it for y. So you're going to have 2 times 0 plus y minus 4 equals 0. Solving it for y, go ahead and add 4 to both sides. So now you know you're going to be crossing your graph at y being 4. All you want to do at this point then is draw a line going in between those two.